today. So if I ask you to simplify 2 times the cosine of 30 degrees. Now, one thing I want to warn you, do not just plug these into your calculators. Because remember from yesterday, a lot of them have radicals in them. Your calculator will give you a decimal. I am always going to say you have to give me the exact value, which is with radicals, not the decimal from a calculator. So we have to know how to do this. So if I wanted 2 times the cosine of 30 degrees, remember our hand trick from yesterday. So our fingers were those angles, 0, 30, 45, 60, and 90. So if I want 30 degrees, I fold in my 30 degrees. And I want a cosine. Remember, cosine is the square root of the bottom over 2. So how many fingers do I have below my 30-degree finger? So it's radical 3 over 2. What happens if you do 2 times radical 3 over 2? Just get radical 3. Okay, we also filled out this table yesterday. Remember I gave you like 4 copies of that table. We'll practice it again in a little bit today. All right, B, the tangent of 45 degrees plus the tangent of 60 degrees squared. So we're going to use our hand trick. Tangent is the square root of the top over the square root of the bottom. Remember, sine was the square root of the top over 2. Tangent is just sine over cosine, so radical top over radical bottom. All right. So tangent of 45. I fold in my 45. Square root of 2 over square root of 2. 1. Plus the tangent of 60. So I fold in my 60. So I have radical 3 over radical 1. Radical 3. All right, so then if I want you to square that, that's just from algebra. That means we have 2 of them, so we have to FOIL. So we get 1 plus square root of 3 plus the square root of 3. Radical 3 times radical 3 is the square root of 9, or just 3. So we get 4 plus 2 radical 3. C, when it says sine squared 45, that means you take the sine of 45 and then square that answer. So 45, fold in your 45 finger. Sine is the square root of the top over 2, so that would be minus 2 times the sine of 45. Cosine of 45. So square root of the bottom over 2. It's also radical 2 over 2. Plus cosine squared of 45. That means you take cosine 45 degrees and square it. Cosine of 45 is radical 2 over 2. So if I simplify that, the square root of 2 squared is 2 over 2 squared is 4. We have minus 2 times radical 2 times radical 2 is 2. 2 times 2 is 4, plus 2 over 4. So I get 1/2 minus 1 plus 1/2, or 0. So on those questions, I realized you could very easily just look at the table that we've already filled in and copy down the radicals. But I'm giving you those questions to practice that because we need to know these ratios. We will use them for the rest of the semester. They're not going to go away, so practice them. Don't just try to copy them down. Make sure you really understand and you can figure those out. Are there any questions? Let's look at this problem. Find the exact value of each variable. All right, this is really like 4 questions in one. In this triangle, I have to find A, B, C, and D. The trig functions only work in right triangles. Is the whole thing a right triangle? No. But we have 2 smaller right triangles. I'm going to start with this triangle on the right because when I look on the left, that one, I don't know any of the sides yet. So I'm going to start here. Okay, the 30 degrees is labeled, so I'm going to use that angle. If I want to find B, from here, B is the opposite side because it's across from it. 12 is across from the right angle, so that's the hypotenuse. What trig function involves the opposite and the hypotenuse?
Cosine.
Sine. Cosine's adjacent over hypotenuse. So hold that thought, we'll use that one in a second. But I could do sine. So sine, you have to have your angle, which was 30 degrees, equals the opposite side B over our hypotenuse, which was 12. I want to find this, and I said exact value. So the sine of 30 degrees, fold in your 30 degrees. Sine's the square root of the top over 2. I have 1 finger above, so radical 1 over 2 is just 1/2. Equals B over 12. So if I multiply my 12, B is equal to 6. Okay, I can find D as well, just using that triangle. From my 30-degree angle, side D would be the adjacent side. 12 is the hypotenuse. Which trig function involves adjacent and hypotenuse? I could say the cosine of 30 degrees equals my adjacent side D over my hypotenuse 12. Okay, cosine of 30. So fold in your 30, cosine square root of the bottom over 2, so radical 3 over 2. It's D over 12. Multiply over my 12. So 12 over 2 gives me 6 radical 3. Does everyone understand how I got those two? I still need A and C. Now, we can continue using these trig functions. If you know some other tricks, you can use those as well. If this angle is 45 degrees, what's this one?
45.
If those angles are the same, what do you know about sides A and D? Those have to be the same. They aren't drawn to scale, they don't look the same, but they are the same. So if you recognize that, you could just say, okay, well, I know then side A has to also be 6 radical 3. If you don't recognize it, you could do a trig function. Okay, from our 45, A is adjacent, D is opposite. What trig function involves opposite and adjacent? Tangent. You could use your tangent to get there. To find C, I could do a trig function. What else could I do? If I know 2 sides in a triangle,
C over 12 equals.
I don't know that they're similar though. Okay, let's do that. So if I wanted to view from my 45 degrees, this was, you can use either, but in this triangle, this would be, you said use the adjacent side. This is my hypotenuse. Which trig function involves adjacent and hypotenuse?
Cosine.
Let's say the cosine of 45 degrees equals my adjacent side A, which we just said was 6 radical 3, over my hypotenuse C. Okay, cosine of 45, so using our hand trick. Cosine, square root of the bottom over 2, so radical 2 over 2. We cross multiply. Divide the square root of 2 over. Can we leave a radical on the bottom? Okay, so I have 12 radical 3 over radical 2. If you multiply radical 2 on top and bottom, you get 12 radical 6 over 2, which would reduce to 6 radical 6. So then I found C. You could have also done Pythagorean theorem. Once you have two sides in a right triangle, a squared plus b squared equals c squared. Could get you the third one. So I don't care how you get it. You'll have to use trig functions to get at least one side. But once you have two of the three, you're welcome to do Pythagorean theorem if you prefer. All right. Why don't you guys take a second and see if you can set up anything here. I am missing something. I should have a right angle marked over here, and I don't. Let's say this is 90 degrees. We're dealing with triangles, so all sides are positive. You have to break that down into 225 and 2, so we get 15 radical 2. I saw a couple people that did a trig function, and they got the same thing there. So it doesn't matter. Now, I know those. So when I come over here, I don't know two sides, so I can't just do Pythagorean theorem. My angles aren't the same. If this one's 30, that one's 60. So I'm stuck. I have to use a trig function. Make sure you recognize this would have to be the hypotenuse because it's across from the right angle. If you get confused by these pictures, you're welcome to even come out and just draw them separately. Sometimes that helps. If you're confused, this is T, this is Q, and we just found this side was 15 radical 2. So if you would prefer to redraw just that one triangle, you can do that. It helps make it a little more clear. If I wanted to find Q, from here, Q is the opposite side. This one is my adjacent. What trig function involves opposite and adjacent? So I can say the tangent of 30 degrees equals the opposite side Q over the adjacent side, 15 radical 2. Okay, tangent of 30. So if we do our hand trick, fold in our 30. So we get radical 1 over radical 3, or radical 3 over 3. Cross multiply. So 3q equals 15 radical 6. Divide by 3. So q is 5 radical 6. At this point, you could just do Pythagorean theorem to get the third side, but I'm going to do another trig function just to practice that. From my 30, this is adjacent, T is hypotenuse. What trig function involves adjacent and hypotenuse? So the cosine of 30 degrees equals my adjacent side, 15 radical 2, over my hypotenuse T. Cosine of 30, so if we fold in our 30, cosine is the square root of the bottom over 2. So cross multiply. Divide the radical 3. Can we leave a radical on the bottom? No, so we'll have to multiply radical 3 on top and bottom. So we get 30 radical 6 over 3, which turns into